Good morning or good afternoon, everyone. Thank you for joining us today for this wonderful webinar by Paul Grossman. If you have not heard Paul speaking before, this is really a good opportunity for you to enjoy his knowledge and his experience. Paul has been doing a lot of work in test automation for over decades now, and he actually now focusing on automation using AI. I'm going to let Paul give you more details about himself and also about the webinar he was going to be talking about. This webinar is hosted by the International Institute for Software Testing, the leader in education and professional certifications. Feel free to go to our website to look at the over 100 courses that we have there. Now, here is Paul Grossman. Paul, please go ahead.
Hello, everybody. Thank you so much for joining this session, which I will have here. There we go. We're essentially a follow-up from our last month's May's presentation. Last month, we were talking a little bit about how to dynamically find elements in a framework to make it smarter, so that we don't have to use our AI resources and tokens in order to go and find and fix and update all of our locators. This is kind of a follow-up to that. We will have a little bit of crossover here, and I'll be doing a little bit more, some demonstrations as we go. So I hope you enjoy this dynamic page weights and pop-up message, or as we call them, toast messages, validations. So a little bit about myself. I have been, as you heard, in the automation industry for many decades. I've been doing this since about 2001, working with Windrunner at the time. And I am also a published author. If you want to check out some of the concepts that you've got in this presentation are actually in Chapter 10 of Enhanced Test Automation with WebDriver IO. I know everyone's sitting going, wait, I use Selenium, I use Playwright. Those books are coming, but the cool thing about this is if you do pick up this book, all the concepts that we have in there, and including the repo that's out there, you can take it and have AI actually convert it from the language, which is in that place JavaScript, to TypeScript, or whatever language you're using and whatever framework you are. They're mostly just concepts and ideas, and I'll show you a little bit more about that. I've touched just about every tool that is out there, as I said, starting from Windrunner, going all the way over to QTP, UFT, Selenium, WebDriver IO, Playwright, and even Applet Tools Autonomous. So I've touched all the open source and a whole bunch of the paid sources, tools out there. And right now, for this particular session, I will be we'll talk a little bit about some of the challenges that one of the main challenges I had, which was having our test automation scripts run quickly and not miss anything that occurs out there. One other thing, I started taking IST courses back in 2001. Linda Hayes was my first instructor and taught me a whole lot about automation. And these courses have been a big influence on my career and trajectory for the last 26 years. So definitely recommend checking out the courses here at IAC, and we're always constantly improving them and moving forward. Some objectives we're going to talk about in this session is logging when particular concepts statements are executed, such as the wait for timeout, and also the wait for state messages. We want to do those as monkey patches. It means we're just going to use the monkey patch means we're going to extend the capability in the Playwright framework in order to do some documentation. And then we'll replace those timeouts with dynamic waits and some things about what it's doing there, like taking in the metrics of the milliseconds that the original timeout hard-coded wait was doing the element count, how to detect spinners, how to wait for a load state, where that gets injected into it, and also hard-coding waits. putting into that dynamic wait. The dynamic wait is going to be able to adjust and say, hey, you know what, you asked for 10 seconds, but I was done in 3. What do you want to do now? You can also force it to say, yep, okay, you wanted 10 seconds. I will wait 10 seconds. We'll get to all that at the end of the session. This is being combined in. As I said, the previous session, we talked a little bit about advanced ways of finding elements, and this is another portion that gets injected into the click advanced function. We'll talk a little bit about how that works, and catching toast messages, which are messages that are in there very briefly and maybe waiting around for the page to build. It might be identified as something that you might want to go and try and catch. So we'll talk about early exits and double catches on that. I always like to mention the challenges of test automation. If you whatever tool you've probably got a recorder that'll go out there, capture data, and capture your objects and build your test right for you. And then you run the test and you get your results. However, 5 minutes later, some pop-up window pops up and ruins your whole execution. So now you have to be able to handle that pop-up window or the toast message that comes up. And once you got that, well, a day later, your data is stale. And then your steps, your process flow changes. We're essentially going to be working in this area of trying to identify a vendor pop-up window while we're also waiting for the page to complete. Our previous one last month, check it out. There is a recording of it talking about when objects change. So we're just going to be focusing on this area over here. I did vibe code this. I know everybody's all freaked out. Oh, why'd you vibe code this? Because it's a lot of code. You'll might be surprised. I vibe coded it in about 24 hours, over one day, and it took about 4 hours to get all of this to the state that we are going today. One thing to keep in mind, yes, you can actually ask Claude or Copilot to go and start a new playwright project from scratch named Back to the Past. That's what we're going to be calling this. And it will go do it for you. And it'll make the directory under the repos directory where I like to keep my repos and go and set it all up. I like that because there's so many things that you do in a setup, but you only get to do it once or twice, a year, and then you forget. What is it? Well, I got to go back to chapter 1 of my book and remember what it is. The AIs are really good at setting stuff up, but always keep a human in the process over there. We're going to talk a little bit about page synchronization, but I want to actually first show you the demo site that we will be going to. And I believe I have it over here. The demo site we're going to be using is one that I kind of built up specifically for this presentation. It's on WebSim. You can find it over here. You can look for the Dark Arts Wizard over here. There's my picture, same picture that you always see. And essentially what it's doing is that we have a couple of different examples over here of building some time circuits in order to get this done, but they take a while to pop up. The one that we're going to do is the most complex one, which is we're going to wait on a pop-up message and a toast message. And if you click on this, it'll show you this screen. My system, but it has a pop-up that says, hey, do you want to format the SSD drive now or later? Well, that's something we'll have to deal with, but we definitely want to embed that into the framework somewhere to take care of it. But it's a random pop-up. Then it starts populating other dates, times, and settings, and we're waiting for a pop-up message, a button to appear here. But while it's doing that, we also get a toast message that says syncing to the Hill Valley time. You'll notice that sat there and came up for about all of 3 seconds. And how are you going to make sure that you catch that while also looking to see if the Back to the Past button is available? The last thing we want to do is click on the Back to the Past button. And this, after a few seconds, will take us right back to our opening site, which was waiting for gas gauges and spinners. You also notice there's a spinner on that page, and that's something we're going to have to be looking for and waiting for. Our major problem with coding is that, we're not always certain how we're going to be able to handle some sort of long wait. Maybe a developer has put in select all from names, and the system is responding in about 45 seconds because there's a million records to go do. And it might be a little time before they go, you know what, maybe you'll just select the top 10 from names, and that 45-second wait becomes a 45-millisecond response. We don't really want to be adding in a wait for timeouts because they're hard coded. If the system starts responding faster, you don't necessarily need 5 seconds. You definitely want to be able to have something that's dynamic. We also want to use synchronization states to enable, like, if a property is true, exists or enables, or if the system or if the browser is busy. And in order to do this, we're going to be creating our own custom function. I like to call it a dynamic wait rather than a hard-coded wait. It's going to do 3-4 things, which is to do an object count of elements in a loop. We'll wait for some spinners. We'll wait for some other items, and then show you how you can push this all together so that it works well. At the very end, we'll also talk about putting in Copilot instructions so that the LLM will remember and say, you know what, if I ever need to use a wait for timeout, I'm going to use dynamic wait instead in order to do that. This is what it really looks like when it's really bad. When I join a project, the first thing I look for is I do a search for our wait fors, how many hard-coded waits are in the system. And you can see there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 17. This test would never complete in less than 17 seconds. We definitely want our test cases running a little bit faster than that. The problem, as I mentioned, the wait for timeouts, there's no flexibility. In fact, there could be too many of them to go through and try and figure out which ones are we going to work with. And it's not on the slide, but we'll talk about it a little bit later. It should have always, if there's a hard-coded wait, a really good reason for doing that. And it's something that very, very few people ever do. I'm going to bring up an example over here. We're going to go over to my one of my systems examples over here. Here's a good example. I'm going to go and just search for wait for load state. There's about 8 of them in there. And then if I go, really what I want to do is, if I just do wait for timeout, how many do we got? 54 in them. And some of them are actually documented with why we're waiting for these things. And a few other ones are not. I have a general rule. If I'm going to wait, I'm never going to wait more than 1,000 seconds. So anything under 1,000 is pretty okay. And it's usually inside of a loop that's actually being done. So there are times that you do need a timeout. But if you ever get to a point where you have 2 seconds here, 2 seconds there, you can see these are commented out. Here's a 5-second wait. You definitely want to go and justify and say, yeah, it's sitting here waiting for 5 seconds. Why? Because, in this case, the browser actually didn't build the page, so we're going to wait 3 seconds and then recycle the browser page to see if we can get out of that. So that's actually an okay reasoning. And it's even actually kind of self-documenting over here. So I would say this is okay. I understand you're waiting 3 seconds for the page to recycle. But you can see it's in a project, any particular project, it can be very time-consuming to go and try and address them all and do that. So often I use, we're going to use AI in order to help us do this. And by the way, a lot of these are pretty similar. So even if I'm saying I'm going to go wait, there's a 2,000 second wait, and here's another 2,000 second wait. Well, this one is sitting here at line 377, and this one is sitting here at 556. And you're not always certain if you know exactly which one actually executed. So the very first thing we want to do is start to go and putting that message out into our console log. And we're going to let AI help us out on that. we're going to do with some monkey patching over here. There's a difference. There's monkey patching and there's wrappers. So monkey patching is a global function extension or override of a functionality that does something, like waiting for a timeout or waiting for a load state. These two are being executed, but I want to know where and when. The only thing I don't like monkey patching, where it's a global function, is like an action like click or select or validate or assert. Well, in those cases, I prefer to have custom wrappers where I can replace the click piecemeal, a bit at a time. And then if something does break, then I know that I'm not impacting the entire system, the entire test suite, and I can quickly get in there and fix it, change it. All I have to do is take the ADV off, and it goes back to a standard click. So these will follow a process over here. Just a little heads up. We're going to actually, when we do a click, we're going to wait for the page to build. We'll perform the click, and then we'll wait for it again. There are some other two other option paths where we wait, but then we see a pop-up, not a pop-up, a toast message, and it's like, wait, we see a toast message, forget waiting for the page to build. This is important because the very next thing might be, hey, I'm going to click on this button and I want to see this drop-down appear. And then the last thing is waiting and click and wait again on a second pass on that. So let me bring up the actual project over here. We'll go over here to, I'm going to go and clear this out because I don't need it. We're going to go to the back to the past project over here. I've got this under my repo, and at the very end of the very last slide, I will give you the path to the repo so you can go download it. It is public. You can go play around with it, see exactly how I did it. And I have a 10-step process that I went through. The very first thing I said I was going to do was like, let's go build this. And here is my test. It's one test out there called Back to the Past. What I wanted to do is go to a particular URL and then wait out there. There's a hard-coded wait. I put those in there intentionally. And then we're going to toggle the sidebar and do a few other changes in here. I don't think the website is in there. So if I go and run this, I'm going to go and give it a run. The only reason it's green is because I ran it on my last approach. There we go. It jumped right over to the site. It made it wider so that we can see stuff. And what's it telling us? Almost nothing. We'll keep this over to the right. It isn't even clicking on. It's supposed to click on the wait for pop-up and then validate that we got a message that said the Hill Valley Toast message appeared. And then we're going to click on that back to the past button over here. Oh my gosh, it failed. It's not in a good state, and that's okay because we're just at the very beginning of it. And we are seeing, we do get some, the system playwright kind of brings us back some information over here. It's that it timed out on this wait for load state, which is waiting for the network to be idle. And that's kind of tricky because, I mean, if you use that, you could, this is actually used as an alternative throughout other frameworks, but it can get tricked, and it can also even become a infinite loop waiting for the network to become idle until the test has timed out, which could be a minute or 2 minutes when the test is supposed to be completing in under 30 seconds. We don't want any of that. So at least it launched it and navigate, toggle the toggle bar. So let's see what's the next thing we want to do. So the first thing we want to do is some monkey patch logging for like the wait for load state. I want to know exactly when a statement for wait for load state load, document content loaded, and network idle is being executed. And you know what? you can ask the AI to go and build a console logger indicating when all of the wait for timeout and wait for log states and click methods, I added those in there, are being executed, what line number, and just go a little step further, when you do a click, I want to know what locator it was clicking on. Tell me that, because if the locator can't be found, I want to know how I'm going to be able to modify it and change it. That's something we addressed in our previous session last month. So do check that out. And in this case, since I'm only doing reporting, I'm going to do logging. I'm going to use, use monkey patching to avoid any wrappers at this state. So what I'm going to do is just to save time. By the way, I had a lot of conversations with my AI. In order to save a little bit of time, I'm going to go and jump forward and go to where we have done this. So here's our monkey logging. You'll see down here, my build test is now going to change to monkey logging. Let's give this another run and see if there's any difference in the output of our test run as it goes. There's our browser. I'll move it off to the right. And look, now it's saying, giving us a little bit of information over here. It's saying, hey, I was waiting for the stop count loaded. I also waited for a timeout. This is giving me exactly what line number, what page, what file, where that was executed. So I can now start building a process where I'm like, okay, I want to change these wait for timeouts, these hard-coded waits. I don't want them doing all this stuff. I want to replace them. You'll also notice on the click, if I go back up here, the click told me exactly which button that I ran over there, and I don't think I really meant to do that, so I'm going to go bring up the terminal. Let me bring that back up here. Do a new terminal, and we'll give it one more just for that, because I really want to talk a little bit more about what we see there. We'll let it run and execute over here. As I was saying, this now is giving us information about exactly where these items are and how much time they're wasting on me. I love metrics. So I love adding up how much time we're being done. This click, as I mentioned, is getting a click by the name of a toggle sidebar. And in that, we could, if that never didn't appear, we could dynamically find that another way. But it does tell us exactly where we're at and adds to some of the messaging that we get on this system to make it a little bit easier as test automation architects to go and find out what's going on. A lot of time being wasted over here, 2 seconds, 3 seconds. And in fact, we had the last thing that executed was this network idle. So let's see if that is our next issue with the network idle. There it is, our messaging being output, as we said. So we're documenting the line for the wait for timeout, the hard codes, and what element was just clicked. And the ultimate idea, the process behind this is, let's get rid of a bunch of repeated lines of code, like waiting for a load state, for a load state of load of dot content loaded, network idle, and also the hard-coded wait for timeout. And one of the problems we have with wait for load state network idle, which you would learn as we go along. First of all, I said it's not reliable because if you have multiple page updates, and we call those AJAX updates at the Java, asynchronous Java updates, back in the day, I'm sure there's another term for it because it's been changing over the years. That can fool it into thinking, yeah, the network's idle. Oh, wait, and I'm done. And it doesn't, you don't have a second chance at it. Also, it could be getting stuck waiting for 2 minutes, and you get a message like, hey, we had a timeout of 30 seconds, which was as long as the test is, and it kind of failed at this line. We don't want to do that. So also, as I mentioned, there could be so many similar ones that you need to have the information where it is located at. So when this is occurring, what I like to do is ensure that we actually have a timeout that is embedded into the network idle in order to ensure that it does not go and go skipping along. And It could be, doesn't necessarily have to be 30 seconds. It could be 5 seconds, 10 seconds. And the reason you can make it 5 seconds is because all of the other stuff we're going to do before it is going to burn some time. And by the time it gets over here, the network has probably been idle for several milliseconds by the time it gets to this point. So your chances are your page is probably done and built. I mentioned this last time. There is an 80 to 20 Pareto principle. 80% of what you want to do can be done with just about 6 actions. I say 6. It's there's one extra action that's on there. It's 80% can be done by 5 actions. We're navigating to somewhere, populating something, selecting something. The important thing over here is the last 2. Clicking on add to cart and then verifying that an order complete toast message appeared. So we want to be able to make the click and the validation smart over there. This is how it looks in code. We would have a click over here. And in order to inject this stuff, we would have do this. We would change the click to a click advanced, and we'd also have to use an expect advanced that AI can just, you can say, write a wrapper for me. It takes everything that click normally has, and we will use it to our advantage in our own custom clicks as we go. So with that said, the first part of this, before we get to the click advanced, is we want to build a dynamic wait. And this is our roadmap for that. It's essentially 4 things we're going to do. We want to have a loop that does multiple things, counts the messages, counts the elements, has a wait so that it waits about 250, 333 milliseconds. That's a hard-coded wait. It's absolutely okay. It's part of the process. And then if it happens to see a toast message, it immediately exits out. If there are 3 static values, this number came up 3 times the same, we're going to exit out of the loop. And if it says exit if a toast message appears, it also should be looking for pop-up messages. So we'll be looking for that. So this is a toast message. I'm sorry, a pop-up message, not a toast, a pop-up message that sits and waits, that is blocking you. Essentially something that needs to be addressed before anything else can be taken care of. That's all in one big loop and with one exit point. The second is looking for any spinners. If there's a spinner inside this, by the way, the spinners would be inside this big loop as well. If you see a spinner, keep waiting, keep resetting the count. It doesn't matter. The static values will go back to 0. And we're going to wait for the spinners to go away. Unless we see a toast message, then we're out. I don't care what the spinners are doing at that point. And then lastly, we're going to roll your own 3-step process. And the fourth item, let me jump back over here. Fourth thing is to check and see, is the count greater than 20 items? That means it's not a blank page. So if it was less than 20 items, we would say yes, refresh the browser and try again. So we're going to try and build that dynamic wait. And this is the item. The first thing I want to go look for is the elements that are on the page. So let me go switch up my, we'll go back to our version over here. And we'll go to our timing and our dynamic waits. So now we're at timing and dynamic wait. And inside of this, we can go find dynamic wait. I don't want to be changing names here. Thank you very much. See if we have, I think I saw it up there. Yeah. So I have a dynamic wait, which is now being injected over here. It's actually part of the go-to. It's once you go to a site, it's probably a good idea to dynamically wait for the page to build. Once you navigate, you could inject this into a go-to advanced and say, go to this, but do some extra stuff for me while while we're doing that. It has a .com loaded weight embedded in here, which we would like to get that eliminated. And we're also waiting for elements to become visible and the actual iframe itself to become visible before we're pretty certain everything is good. So let's go give this a run and see what the difference is when we give it a run. Hey, maybe it'll pass. There we go. So we have our wait for timeouts, and we're getting a lot more information and data over here. It's telling us, hey, this was stable. Kind of figured out that it was stable. So it said, hey, you were asking for a 500 millisecond wait, and it actually said it waited a little bit longer, which is okay. Your stability, you definitely want to, it's your dynamic weights do need to be flexible. They should be able to wait longer than what your hard-coded weight, because your system could be getting slower. Your developers might be putting in more select all instead of select top 10 in your systems over there. We're also counting how many visible elements are there. I don't have a demo in this particular session for that, but if the page did end up being completely blank, you would get less number of elements. You get somewhere about 10 or 1 element being visible on the page. Again, you could build this into it and say, hey, okay, the browser kind of went wonky. I want to have it refresh and see if we can take a second shot at this. I don't want to be spending time trying to come up with a bug written for against the system, because the one time the system, the internet went down, or something was happening with the validation system and it went away and can't be reliably reproduced. I don't want to be wasting time with that. I want to take the assumption that the internet is 99% accurate, and I want to give a pass for that 1% where it's accurate. If I can see it twice, hey, that's a bug, and that's where my meat and potatoes comes from. All right, so we are essentially adding in the weights. We're looking for the weights and timeouts, and our dynamic weight is polling for element stability. And we'll get back over to our presentation over here. So we're looping around looking for the count of elements to do that. Also important, don't try to look for all the elements. We want to design this as a drop-in replacement for a wait for timeout. So if we just change wait for timeout to dynamic wait, nothing else changes. You can keep the number that's in there. It just gives you more metrics now. And as I said, we don't want to log the small weights that are inside of this. We can tell the AI not to do that. We can log the speed difference, how much faster or smaller. We could even force it to have hard-coded wait by telling it to wait not 2,000 milliseconds, but 2001. We'll talk about that in just a minute. Here is that static loop count. It is a function that counts all the elements on the page. The important thing here is these are the elements you should be looking for. Don't try to do and look for every visible element, because that will return hundreds or thousands, visible or not visible, and it slows down the whole system. So don't do this. Do this. Get a selector of a limited number of elements. These are the things that are most likely going to be appearing, changing, modifying as the page gets built, and then just return the length of how many elements that you got when you were counting it up. And that's all going to go inside of a element. The next thing is we want to go to, that's going to go inside of the loop that is going to wait for those to become static. Next, we want to wait for a spinner. You're going to have to get this from your actual application. Every developer does a spinner completely differently. So I'm just using a generic locator spinner over here. And you also want to make sure that it's visible. So we're looking for any visible spinner. The biggest challenge I had was that it was saying, I see a spinner. I'm like, I don't see it. Well, let me go in and go and try and find that for you. One of the things you can do is you can say, pick a locator. If you do that from Playwright, and it'll just pop up a website. Let's say if I go to Best Buy, it will. Let's try bestbuy.com. Let's try that. Just use it just for fun. There's Best Buy. And what you can do is you can actually go and take a look at these items as they go. Let's see if I can generate a spinner up here. There was a spinner, but it's really brief. Best Buy's got really fast responses that are on the system over here. But the point I'm trying to make is that you can always go and use this AI to go and pick a locator and go and get the element that you're looking for. And let's say if I want credit cards, it actually tells me, hey, the element you're looking for is get by role, link, name, credit card, which will be a unique locator, which is nice. Do the same thing with a spinner. Just click on the spinner and it'll tell you exactly what the description is of that element when you're spinning out there. All right, that was a little side chip over here. And it also gives you two different ways of finding that. You could find it by credit cards or you could find it by this. Please don't ever, this URL. No, that's going to be changing numbers all the time. And a link called credit cards, you might be able to find it, but this is the best way. Get by role is the primary way to get elements in Playwright. All right, so let me see if we have the spinners. I will bring that up because that's what I was talking about. So I am going to go over, see if we are at, spinners and a pop-up. Let's give this another run. Now we're looking for a spinner. I'm going to sit here and say spinner. And that is on my test. I don't want that. I want that in here. Spinner. I don't have a test named spinner. But over here, my console logging, I can now find spinners. And these are the generic classes that AI came up with that says, pretty good chance that these, these are going to be a description of a spinner. And as I said, it's always best to go right directly to your website and get the description that's going to match and use those out there. And tell the AI, make sure these are visible spinners, not invisible ones. Let's give this another run. Take this out. We shall see a test. And we'll give it a little chug over there. There we are. Let's see what our response is. Are we able to actually click on it? Oh, look, we got to our page and we're actually looking at a spinner. We've actually highlighted. I like putting highlights in because it tells me, hey, I found something that's out there. Not quite working quite the way I wanted, but it's moved beyond. And I like that. And we're also getting some output out here. We should see that it found a spinner out there. Let's go see if I found one. Oh, it did not. So we're going to move to the next one over here because it is trying to find the spinner, but it's also at the same time trying to find that format, the SSD pop-up at the same time. So we're going to move on and try to go to our next one. Let's see, because we want to do that. Next spot is exiting for a toast message. So we are in the process. By the way, this takes a while when you're talking with the AI to get it to do what you want it to do. Our next process, we're going to roll our own page wait. As I mentioned over here, the wait for load state is a network idle. I don't want to have all of this peppered throughout my entire framework. I want it all inside of one location. And so if I go to, let's see if I go to, we'll go and I want network idle. idle. Did I misspell it? Sometimes I do. Work. And Murphy's Law. What's going on? IDLE. It is not in there. We're looking at spinners. How about my weight? 4. All right. Well, we're getting down to our last 15 minutes, so I do have to get this going along pretty quickly. So I'm going to go and to our next branch over here, which is number 6, I believe. Yeah, it's actually roll your own one. So yeah, I just didn't have the right branch open. So there's our roll our own items over there. So we're going to go look for network idle. We have 1 hit over here. We can now eliminate all these guys. And by the way, note that I've got a timeout of about 5 seconds because everything else that we are doing over here, looking for the spinners and the counts and the pop-ups, they take up a little bit of time, and this is just like the belt and suspenders. All of this should execute within milliseconds out here. We'll give this another run, see what our results look like over here, and see if we actually pick up on that. We'll move this guy over here. And now we're actually going through this. And guess what? It's sitting there waiting a really long time. Some of the changes I've made over there, it's now counting up 186 visible elements. It is polling. AI doesn't always get it correct. So we got about 15 minutes. We should be able to finish this off. This is the great thing about AI. When you start doing this, it doesn't always know the right and best way to do this. So you're usually having a conversation with it for quite some time. You can see this is my entire conversation over here. It actually found the button, but it's taking a while. Then it found this system alert. And we want to be looking for a button that says later. And if it sees it, it catches it. The flashing over here says we still have a spinner. So our page ain't ready. It's not even time to go and click on that button. And it did get to the point where it saw it, but it waited so long it timed out. This is going to be so frustrating. No, just kidding. We're okay with that. We're going to move on to our next spot. So I've already got these guys built in there. We don't want that infinite wait. We want to have a timeout of 5 to 30 seconds out there. I like 5 seconds, even though the slide says 30. Last thing is the page blank. If we do our counts, we get through all of this, and at the very end, it says the count is less than 20 elements on the page. You might have something like this, where there's a page and there's nothing on it. Or there's a page, but it couldn't reach it. This is less elements than a login page will have. If you do have that built into your dynamic wait, tell it to refresh the browser, do the loop again, and wait for it to build, because that can handle rogue internet issues. All right. We've gotten kind of through that. I'm going to go double check, see where we're at. I think we're at 7. We need to kind of speed up and replace some of the items that are up here. So our next thing is, now we've got a dynamic wait. That's going out there. It's looking for pop-ups. It's handling those. It's looking for toast messages. And you may have written like this. You have a click advance, and the first thing it's going to do is click advance and then wait for the dynamic wait, which is okay. But the better approach is to have it listed twice. When you do a click, the first thing is wait, because you might be waiting from some build from the previous click. We might have been clicking on 2 or 3 other items right in a row, and it didn't finish the click, especially if the click, the dynamic wait, exited out in order to catch the toast message. And it's still waiting because the toast message maybe came up, got validated, went away. The pages might still be building. So we do a dynamic wait first, then we perform the target click, and then we do a dynamic wait again. This basically puts 2 waits together each time you do a click, 2 clicks in a row, and it will be able to catch that page the validation of the toast message, even if it exits out quickly. So there we go. I'm going to do a click advance to do these two items over here. This is how we're running the test over here. We're going to now click advanced for those top pop-up messages. We're going to sync with the Hill Valley pop-up and then go back to the past. Very simple process. And verify the construction of meaning takes time, which is on the very first page. And this is it right over here. The click is doing the dynamic wait, which is looking for a random pop-up. It's looking for a toast. It's a generic pop-up. And then you go through and say, okay, not now, later, whatever it is that's common to clear out the pop-up. Even clicking the X in the upper right-hand corner. Waiting for your spinners, and then waiting for the count to be stable. And if it is stable, then you wait for those last three states, and also making sure the page is not blank. We got all that. We're injecting it into our click advanced in order to make this just a little bit faster so we don't go and time out. So this is a little, I'm repeating myself over here a little bit. We're embedding the dynamic wait, doing the click, and guess what? The session from last month, we talked about if that button, you can't find it, like back to the past doesn't exist. There's different ways to go and class switch, attribute switch. I definitely recommend checking out our previous session from last month and learning how to do this. And essentially I said we're doing two things. We're doing a click, let's say add to cart. For an example, we're doing that dynamic wait, but we did a click, and then there was a toast message that popped up. Well, our next thing is to validate that added to cart on a toast message popped up. We do that, and we do another click. This is the reason we do a dynamic click, because this could have been executed out early. This dynamically allows us to wait between two clicks and make our stability a whole lot easier and better. All right, let me go take a look at our example over here. We're going to give this one a run. This is our speed up and replacement, so we don't have a whole lot of tests out there, repeated steps anymore. We'll give this a run. Seriously? Name of project. Okay, I don't know why I did that. Chrome and Firefox. What am I looking at? Back to the the AI decided to do something a little funky. It added more browsers to me, and we're not talking about multiple browsers today. So I'm going to move on to number 8, our click advanced. That's right, we were talking about click advanced. And let's give this a run. We really shouldn't have those other browsers in there, but AI gets very creative when it goes along. Okay, it's running in 2 browsers. Okay, well, we got a sidetrack over here. We did get into the main thing. We cleared that pop-up. We should be catching the toast message up here. It cleared up here, caught our Hill Valley item over here. Is this going to actually complete running 2 different browsers at the same time? I hope it does. It actually highlighted this one and said, yes, I'm moving forward. So one of these 2 test cases actually passed. And there's our last validation, which is the meaning of this. That one actually passed on Firefox. Chromium is still sitting there. So there's always more stuff to look at for different browsers when you're starting to put this together. So as I predicted, Firefox works. Chromium failed on that one, and we got to go back and look at it. But I did add the click advanced that covered everything that was in there. So let's go on to number 9. Our last item is this. Let's go back over to our process here. We're picking up random pop-ups. So even though this came up, we picked up on the later button, which the loop is going through. The dynamic wait is saying, hey, let's do this. Click advanced is now waiting for the pop-up toast message. And by the way, the expect is also waiting to see if it can catch it, because these things could happen in a different order, But if you have an expect advance and a click advance, and they both execute the dynamic wait, they will pick this up in either order. Doesn't really matter. So it's basically going through, picking up the toast message, synchronizing with the Hail Valley, closing that pop-up, and we are on our way out. As I mentioned, you do it twice because we want to catch this or the pop-up at the same time. And we're just down to our last few minutes over here. Our last thing is smart options, which is, what if you want to force that wait in there anyway? Well, these are the things that I like to put in there. If I have a dynamic wait ending in 1, it will actually say, okay, after the end of all this optimized waiting stuff here, I waited there, let's say 300 milliseconds. I figured out it was a good page. I'm going to wait that 5 seconds anyway, the one that you asked me for. And it will hard code that in there. It will also mention saying, hey, I hard coded this wait, but you didn't give me a reason why. Remember at the beginning, I said waiting, hard coding waits really need reasons. Well, my dynamic wait allows you to do a hard coded wait and then give a message saying the database is still taking longer than 3 seconds. Always have a reason for a hard coded wait to address later. Let's go take a look at that final run. This is our hard-coded wait. Let's see if we can get this to execute over here with our hard-coded wait. It's going to be mentioning that there is one that's popping in here with a little yellow sign, and there it is. It said, hey, you did a hard-coded wait. You didn't give me a reason. And if it does have a hard-coded wait, and it does have a reason, then we are good. This is at line 18 of our of our spec. Let's take a look at line 18. Yep, there's a hard-coded wait, and this one is a hard-coded wait, but it has an extra message in here. One thing I would like to point out, while I was building this, I tried to tell it how to not wait for an element, not exit out when we've already determined that we found a toast message, and it decided to add it as an extra variable. I'm not a fan of extra variables, so if you see your AI doing this, adding more variables, tell it to knock it off. In fact, how do you tell this to knock it off? I mean, you could be chatting with it the entire time or in this process and say, hey, do this, do that, do this, do that, and get all the way to the bottom. But these conversations, it tends to forget in the middle of it. So the last thing I'm going to mention to you before we finish up over here is let Copilot and Claude in on your secrets. And you can tell it, go build me a pilot Copilot instructions that says, do certain things like, hey, if you have to use, don't use a wait for timeout. Use a dynamic wait. It's okay if you want to put in 5 seconds. And clue it in as to everything that you've been working on building. And it will always look at that when you do start building test cases. Let's go take a look at an example of what it looks like. And then we will be done for today. Here is our spec. And we're going to go over here. And where is this hiding? It's hiding under GitHub. There's my instructions. And I have asked it to do these. I want to do a hard-coded wait convention showing how this is done, how it wants. I want to put in messages, how you can use a 1 to make it a hard-coded wait so you can address it later. All of this stuff has been added because I asked this little AI to please and go and do that, which was add Copilot instructions to use this and dynamic wait when a wait for timeout is needed, and it added all sorts of other directives that are in there, which is kind of cool. It'll always look at this as the memory. It will not forget it when you're going for line by line. This is an entire summary of everything that got implemented during this presentation: toast mode notifications, the advanced click, hard-coded waits, And I asked the AI to build that up too. Could put that into a documentation item. And let's get back to our final slide over here. Like I said, let Copilot and Claude in on that. Tell them that you want to save it in a Copilot instructions under GitHub. Claude has a slightly different format and location for that. But which one you're using, go for that. Oh, and by the way, if you're one of the tricks I've been learning lately when I run out of tokens is if I run out of tokens for Claude, I'll switch over to Copilot or vice versa. You can tell inside the Copilot instructions or in the Claude instructions to go reference Copilot instructions. So you don't have to copy all the text that's in this into a different file to have Claude. You can just say, Claude, go look at Copilot. Will you please? Make friends, shake hands, have yourself a great day. That is the end of our presentation here. I hope you enjoyed all the cool stuff that we had here to show off. And this is where my GitHub link is. It is a public link. You can go check it out, Back to the Past. And that's it for me. I'm going to turn it back over to Magdi. Thank you very much for having me today.
Paul, it is always a pleasure to have you on our webinars. It's a richness of information. Thank you so much for sharing your knowledge and your experience with our audience. Let me look here to see if there is any question from the audience. No. Obviously, people liked what you had to say. Thanks to everyone for being with us today. This webinar is being recorded and will be made available at the IIST website. Again, Paul, thank you so much, sir. Thank you so much.
My pleasure, always. Thank you, sir.
Thank you.